Hey everybody, we're talking about side angle side congruency today. Let's see exactly what that means. It says side, another side, and in between we have the word angle. That is because we want exactly that same thing to happen in our triangle. We want to have a side, another side, and the angle that's in between those sides to be congruent to corresponding sides, angle, and side on the second triangle. Okay, so what that's going to look like here would be side AB congruent to side DE, angle A congruent to angle D, and side AC congruent to side DF. Okay, this is now giving a side, an angle, and a corresponding side congruent to side, angle, and corresponding side. And how we would write this in a valid statement, we're choosing this side first, right? And we're going from B to A. So I would say BA, and then from A to C is congruent to triangle. Well, I want to make sure that I'm corresponding, so I'm going to go from E to D, because that's my first side. And then we went from D to F. Now I can check my valid statement. I should notice that B and E are corresponding in my valid statement, and they're congruent on the triangle. BA for a side should be matching with ED for a side. Okay, I can check all combinations. This is my valid statement. Now, let's look at some proofs that are going to be involving side angle side. This proof tells us, given D is the midpoint of AC and BE. Alright. We want to prove triangle BCD is congruent to triangle EAD. Well, our first statement and reason is always our given information. D is the midpoint of AC and BE. We know that because it was given. Okay, again, that's always going to be our first statement and reason. Let's mark down on our picture what that means. Well, I don't exactly have anything congruent quite yet, so I don't actually have anything to mark. Before I can mark it, we need to state that things are congruent. So in my second statement, I'm going to have to use that piece of information. D is the midpoint of AC. Well, if D is the midpoint of AC, that must mean that AD would be congruent to DC because it split AC into two equal pieces at point D. And that is a definition of midpoint. Now, going under the same definition of midpoint, I can use the same piece of information from step 1 to split up BE into two separate pieces. So I know that BD must be congruent to DE. I can list that under the same statement for the same reason. Okay, so that's step 2. Now let's just mark this. AD congruent to DC, and BD is going to get 2 marks. DE is also going to get 2 marks. Alright. The next thing that we want to look at is what else on this triangle can I get to make these triangles congruent. Now, if I could figure out a way to get BC and AE congruent, I could use side, side, side. But I don't see anything in my information that's given or anything from my picture that can show me that these are congruent. So maybe I'll have to think of something different to do. Well, I do notice that I have 2 intersecting lines, and I do notice that I have angles in those intersecting lines that are also part of my triangles. So, is there any way that I could get those things to be congruent? Yeah, definitely. These are vertical angles. So let's mention these angles. We're talking about angle BDC being congruent to angle EDA, and that again was the vertical angle theorem. And let's just mark that now. BDC is over here, and EDA is congruent. Now I should see exactly what I need. Right? I have a side, an angle, and a side. And a few minutes ago we just said that that is a way to prove triangles congruent. Over here as well, I notice I have a side, angle, and side that correspond. So I can now say with confidence that I have congruent triangles. So step 4, what we're trying to prove is triangle BCD is congruent to triangle EAD. I've got the triangles I want. All the sides that I'm looking for are corresponding, and we got that using side, angle, side. Okay, so here's another problem that you can try out. Grab yourself a piece of paper, copy down the picture and the given information. It only takes an extra second to do, but it's worth it because you can start marking things on the picture itself. So take a minute, try this problem on your own, pause the video, and resume it. We'll discuss it. Alright, how did you guys do with this one? Let's see. We're going to always start off our first statement as our given information. So we have ln bisects angle MLO, and it tells us LM is congruent to LO, and that was given. Okay, it's always our first step. We don't have to do any thinking for this. It's the same information and the reason given. Now let's see if we can mark anything. Do I have anything that's congruent yet? Yeah, I do. I have LM congruent to LO. LM congruent to LO. Remember, I'm only going to mark when I know for certain that it's congruent. I have to state it before I can mark it. Here, ln bisects angle MLO. We don't have anything congruent quite yet, but we can state that things are congruent based off of this information. And what exactly would that be? Well, here's ln. It's bisecting MLO. That means this piece of the angle should be congruent to this piece of the angle. So let's state that. We want to say that angle MLN is congruent to angle OLN. And that's based off of the definition of bisect. Alright, well, I notice already that I have an angle and a side, right? Side, angle, over here, side, angle. I should be thinking right now, I need another side, and I need it to be this side, because it needs to be side, the angle sandwiched in between the other side. So I got to figure out how to get ln congruent to, well, itself. That's actually a lot easier to do. I know that anything is congruent to itself through the reflexive property. So I'm going to state that ln congruent to ln, and that's reflexive property. And how we mark that is we're going to mark it with an X, showing that it's congruent to itself. Well, I have everything that I need to say that these triangles are congruent. So let's state that. Triangle LMN is congruent to triangle LON. I took a second to pause just to make sure that I had the proper valid statement written. I went from LM to N, so I need to follow LON. Okay, and we prove those triangles congruent using side, angle, side. Now, what we're trying to prove is angle LON, that's this angle here, congruent to LMN, which is this angle here. And seeing as we have two congruent triangles, we know that all the parts of those triangles must also be congruent. So I can state with certainty that angle LON is congruent to angle LMN. And we just said that it's because the parts of congruent triangles must be congruent. That is CPCTC. And we'll finish this off with a little crossing swords this time. Okay, hopefully you guys did okay with that one. If you want to try and check out the documents page on the website, you might be able to try some more of those practice problems from the class worksheet side. Let me know if you have any questions about this stuff. There's a comment section in the website. Maybe I can put up a couple more videos if you guys need them.